In this video, we're going to compare the DeepCool AK500 to the DeepCool AK620 using this test bench right here. The information in this video can also be found on my website at pcanalytics.com, and the product links can be found in the description below. With that in mind, let's start by looking at some qualitative metrics. Both coolers show the side of the cooler that would face the RAM. With that in mind, the AK500 will not have RAM clearance issues in most setups, while the AK620 will overhang the RAM slots. Additionally, the AK500 uses a single fan, while the AK620 uses two fans, and it is possible to add an additional fan on both coolers. In regards to installation, both coolers are relatively easy to install. Next, let's dig into the performance. We're going to cover two sets of graphs, one normalized by percent speeds and the second normalized by noise levels. Note that these graphs are created by using machine learning models to help break down the performance using over 1 million data points in an open case. This means that performance may differ depending on your case's airflow and your CPU. To orient you to the graph, the left side shows temperatures corresponding to the solid lines, with the right side showing noise levels represented by the dashed lines. As a general rule, lower is always better for the data shown. With that in mind, we will first look at the performance on an idle CPU, which is assumed to be using 30 watts of power. When comparing the AK500 cooler in red to the AK620 cooler in blue, both coolers have similar cooling at idle temperatures across the board. Given that neither fan is expected to go above 50% during idle, sound is not a consideration. As we increase the watts to 105, which is what the CPU is rated for, we can see that the AK620 cooler begins to noticeably outperform at lower RPMs, but this benefit diminishes as the fan increases to 100% fan speed. Additionally, when considering sound, the AK620 is noticeably louder at higher RPMs. Next, we will look at the CPU overclocked to 125 watts. This shows that the AK620 provides materially better cooling performance at noticeably higher noise levels. For the second set of comparisons, we will look at the performance for a given noise level. The graph shown has noise on the bottom axis, while keeping temperatures on the side axis. Note that lower is still better for this graph. When comparing the coolers by normalized noise levels, we can see that both coolers perform similarly at idle CPU levels. As we increase the watts to 105, we can see that the AK620 cooler begins to outperform across comparable noise levels. And as we increase the watts to 125, we can see that this trend continues. Overall, the AK620 cooler has materially better cooling performance for a given noise level, making it the winner for this comparison. If you enjoyed this video, you should check out this one. Thank you for watching.